Hello everyone, good evening. This is Shambhavi, your physics master teacher. Hope you are all doing good. Just let me know if my audio is clear and video is also clear. Just let me know. Let me check in my phone as well. How are you all? I think audio and video both are fine. If you are there, just respond in the chat box. Good evening to everyone. Yes, Shrikant. Good evening. Okay, so hope audio and video both are fine, and I hope that you're all watching this session and you're following the session. So today our idea is to discuss the chapter motion in a straight line. So in the previous two videos, what we had done, so we have discussed about the units and measurement chapter. It's a one-shot quick revision session followed by one session on practice question discussion. Okay, we have discussed some questions from question bank and the previous question papers. Okay, so keeping your upcoming first test in our mind, so we are having a complete revision session. So we are done with first chapter and its practice question. So now today we are going to discuss with the second chapter, that is motion in a straight line. Okay, so again this lecture will also follows by a discussion on questions, practice questions like 2 mark, 3 mark and 5 mark, and even the numericals. Okay, because this chapter there's a probability that 5 mark numerical can come from this chapter as well. Okay, so that is our idea. So we will have a quick revision for today, and in the next session we are going to have a practice question discussions. Okay, so that is the idea. So we'll just begin with the chapter. Yes, if you are there, kindly respond in the chat box that you're following the session, and hope your quick revision with respect to your first chapter is also done by this time, so that you can go ahead for your next chapters. Just let me know. I'm waiting for your response. Okay, so you mean to say the motion in a straight line, you can't understand that this chapter, right? So today you are going to get most of it. Okay, let's keep our target that you are going to understand most of the concept in this chapter. Okay, just follow from the beginning to the end. Okay, you're not supposed to leave in between or something like that, or suddenly joining after some half an hour. It's not going to help you out. So we are going to have a quick brief discussion and a crisp revision, which will definitely going to help you, okay, to understand most of the concept in this. Okay, yeah, so we'll quickly have a view that what are all the topics in this chapter, and we'll begin with one by one. So the chapter name is motion in a straight line. So the name itself is telling us that here we are constrained to discuss about the motion of a particle or an object which is moving in a straight line. Okay, so here in other words we are just sticking ourselves to one dimensional motion. Okay, we are sticking ourselves to one dimensional motion. We are considering only the particles which are moving in one dimension. Okay, it is moving along a straight line. It can just go in this direction and come back in this direction. So 2-dimension and 3-dimensional motion we are not considering. Okay, it's a very simple, a very basic type of a motion, I can say. So we are restricting ourselves for motion in a straight line. So the subtopics are going to be introduction. So where we just discuss like what do you mean by motion, how do you define position, vectors and all those things. And then we have to define velocity, and then we had to define acceleration. Okay, so again, it is like average velocity, average acceleration, or maybe a uniform velocity, non-uniform velocity, uniform acceleration. So all those concepts we learn here. Then we will move on to the graphs of one-dimensional motion. Okay, it can be position time graph, velocity time graph. Okay, we will look for the graphs of one-dimensional motion corresponding to different situation. Okay, and then our job is to the most important, like most means the most important concept of this chapter, that is kinematic equations for uniformly accelerated motion. Our whole idea of this chapter is to understand this concept very clearly, where we try to derive 3 equations, and we had to remember that till the end of your second PUC or your competitive exams, because now and then you will see we will be using those equations. Okay, so what and all you learn in the first 4 to 5 chapters of your first PUC is going to be a solid foundation for your second PUC, your competitive exam and everything. Okay, it's not that you learn today, you forget tomorrow. No, you are not supposed to do that. So wherever you go, these equations and these chapters are very fundamental. Okay, so please understand them very thoroughly so that it will become easy for you in the next year as well. Okay, and then the last concept in this chapter is equations of motion under gravity. This is just a slight modification of your kinematic equation to one specific case where the motion is only under gravity. Okay, like a free fall case we will take and we'll discuss there. Okay, so this is the brief idea of the chapter. So let us learn one by one quickly. So if you are just there, just give me a thumbs up or respond in the chat box that you're following and understanding. Okay, yeah. So the first concept is, what is mechanics? Okay, most of the time I might have already used the word like mechanics, maybe in units and measurement as well. So what do you mean by mechanics? So here mechanics means we are going to deal with the objects which are maybe at rest or maybe under some type of motion. It may be uniform motion, non-uniform motion. Let us not bother about it right now. Let us say we are going to deal with the study of motion or the state of rest of the object. Okay, so we just consider if some object is at rest, okay, why it is at rest, okay, for how long it may be at rest, all those things, like some objects which are at rest, what are all the forces that might be acting. So all those comes under your mechanics. And also if some object is in motion, so what type of motion, we'll try to describe the motion of the particle. So that type of study or that particular branch of physics we call it as mechanics. Okay, so in mechanics we can broadly classify into statistics and dynamics. Okay, so illi statics andrenu. Okay, so it is classified into statics, so it is statics and dynamics. Illi statics andre enu? So this word will somewhere tells us that statics means it is something at rest, right? We are going to deal with the object which are at rest, so we call that as statics. Okay, so statics means something at rest. Okay, and dynamics andre nam gottagate, these are all very general words, right? Dynamics andre objects which are in motion. So we study the objects which are in motion. Okay, so these are the 2 broad classification of mechanics. One is statics and the other one is dynamics. Okay, hope you're following. Yes, Shrikant. Maybe like 2 hours. That's the plan for today. Okay. So we are hoping to complete the chapter at max by 2 hours. If something is left out, that will be discussed while discussing with the question and answer, practice question. Hopefully within 2 hours, most of the concepts will be covered. Okay. Yeah. So next is in dynamics, because to study the object at rest means it's a very small portion in mechanics. Okay, most of the time we will be dealing with the objects which are in motion, which comes under dynamics. So illi again we can classify into two terms. Okay, so one is kinetics, the other is kinematic. So ಇಲ್ಲಿ kinetics ಅಂದ್ರೆ ಏನು ಮಾಡ್ತೀವಿ, here we study the motion or we study the motion of the object. Along with that, we try to consider what is the cause for the motion. Okay, so ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, in the case of kinetics we deal with the study of motion, also the cause for the motion. So ಇಲ್ಲಿ just motion ಅಂದ್ರೆ ಏನು ಅಥವಾ how to describe the motion ಅಷ್ಟೇ ಅಲ್ಲ, ಅದಕ್ಕೆ ಏನು ಕಾಸ್, ಯಾವ ಫೋರ್ಸ್ ಇಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್, ವಾಟ್ ಇಸ್ ದಿ ನೇಚರ್ ಆಫ್ ದಟ್ ಫೋರ್ಸ್, ಹೌ ಇಟ್ ವಿಲ್ ಬಿ ಚೇಂಜಿಂಗ್. ಸೊ ಅದನ್ನೆಲ್ಲ ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ ಆ ಬ್ರಾಂಚ್ ನ ಕೈನೆಟಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ ಏನ್ ಹೇಳ್ತೀವಿ, ಕೈನೆಟಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಅದೇ ತರ ನೆಕ್ಸ್ಟ್ ಏನ್ ಬ್ರಾಂಚ್ ಇದೆ, ಕೈನಮ್ಯಾಟಿಕ್ಸ್. ಸೊ ಇಲ್ಲಿ ಕೈನಮ್ಯಾಟಿಕ್ಸ್ ಅಂದ್ರೆ ವಿ ಜಸ್ಟ್ ಡೀಲ್ ವಿತ್ ದಿ ಮೋಷನ್, okay, or we'll try to describe the motion of a particle without considering the cause of the motion. Okay, here we don't talk about what is the nature of the force which is causing the motion, or what is the how the force is changing. So all those things we don't bother. Okay, so what is the cause for motion annaduna we are not going to study in kinematics. We only try to describe the motion of the body. We'll just see whether the object is in motion. Okay, it is in motion. What type of motion it is, we try to see whether a uniform motion or non-uniform motion, acceleration idya ilva. So all those things we try to see. Okay, but we never bother to see what is the nature of the force. Okay, so ನಿಮ್ಮ fourth chapter, that is laws of motion idala, or Newton's laws of motion. So that is a kinetics, because alli we more tend to learn what is the nature of the force, how it is changing, what is its effect, and all those things we are going to study. That is your kinetics. But each chapter motion in one dimension, or maybe your motion in two dimension, that is your next chapter. Okay, so motion of an object in a plane, that is also going to be kinematics. There we are not going to bother about the nature of the force that are acting. We consider only the description of motion. We try to describe the motion. What is its velocity, what is its acceleration, what is its position, what is its displacement. That's all. We never bother about which is causing that type of motion. Okay, so that is the slight difference between the word kinetics and kinematics. Hope it is clear. Yes, Shrikant, I will try to include Kannada and English mixed language. Okay, ನಿಮಗೆಲ್ಲ ಅರ್ಥ ಆಗಲ್ಲ ಅಲ್ಲಿ ಡೆಫಿನೆಟ್ಲಿ ಹೇಳಿ, ಮತ್ತೊಂದ್ಸತಿ ಕನ್ನಡದಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, is that fine? Hope you are aligned with me now. ಎಲ್ಲಿ ಅರ್ಥ ಆಗಲ್ಲ ಪರ್ಟಿಕ್ಯುಲರ್ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕ್ವೆಶನ್ ರೈಸ್ ಮಾಡಿ, or you tell me that you need one more time of explanation in Kannada specifically. That time I will completely go with Kannada, or else usually I mix Kannada and English in between. Hope that will be fine with you. Okay, fine. Thanks for your response. The next is, what we are trying to do is we are just trying to learn some new terminologies which are needed to describe the motion in one dimension, or in generally any type of motion in physics. Okay, so you no need to worry about much about all these definitions and all, but it is good if you are familiar with those words. Okay, so that I'm giving you all those words, because if someone uses these words in front of you, you should not feel like, okay, something new is being told to you, but your teacher is not told to you earlier. Okay, so let us try to improve our vocabulary in terms of physics as well. Okay, the words which we'll be frequently using. Okay, yeah. So what we are trying to define is, as we said, we are interested to study, motion of an object in one dimension. So we should be able to distinguish between rest and motion. I should be able to identify. So when I can say some object is at rest and when some object is at motion, I should be able to mention that. So in that case, how can we define rest? So ಯಾವಾಗ ಹೇಳ್ತೀವಿ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ? Yes. So we can say that if its position is not changing with respect to time and surrounding. With respect to the surrounding, a object in a position change agbardu. With respect to time also, as the time passes, the object should be there only. Position change agbardu with respect to time and surrounding. So then we say that the object is at rest. Okay. Similarly, motion, when we can say the object is in motion. So if it changes its position with respect to time and surrounding. Okay. So for example, I hope you can see this. If I keep this pen like this only for a long time, or for now I can say the object is at rest because it is still here. As the time is passing, when I am explaining, the object is still there. The pen has no leg, it is not moving around, right? So it is still there on my hand, correct? So this is rest. Now if some objects, or let us say I apply some force, but right now we are not bothered about what is the type of the force and all. So I can just say that the object position is changing with time, is moving front and back like this. Or when I'm writing on the my tablet, so the pen will be moving, it is having some type of motion, definitely, right? So if the position of the object is changing with time and surrounding, then we say the object is having motion. And if it is it is not changing, position is also not changing with respect to time and surrounding, we say that the object is at rest. Okay, hope it is clear till here. Yes, yes, Shrikant. So our idea is to mix both the language, okay, because we are used to our mother tongue like Kannada, and we will be writing exams in English, so we are using both the language. Okay, so that's the only reason why we usually explain more in English, because at the end of the day you will be writing your exam in English. So you had to be, after some time you had to get used to writing English in a better way. Okay, is that clear? That's why I usually stress students, to talk more in English when it comes to subject. Okay, apart from that, you can talk to your friends or with anyone with your own comfort language. For you might be this Kannada. So when it comes to subjects, so let's hope that we are improving our English so that it gives, when you sit to write the exam, you should not to worry about, okay, I'm writing in English. Okay, so don't worry when you come from 10th standard to first PUC. So there is a huge gap, in terms of syllabus wise as well, in terms of language. Okay, the vast syllabus, that's the main thing. So initially you find everything difficult, everything is new word to you. So initially you find everything is difficult, but nothing to worry. With time, all of us will improve, definitely. Okay, yeah. So moving ahead, then there is one more definition or one more word which we will use, that is rectilinear motion. So rectilinear motion andre enu? So ille ide word linear anta. So linear andre enu? One motion in a straight line. It's like straight line. Linear means straight line, right? Maths alla use madirtira, correct? So linear equation andre it is nothing but straight line. So rectilinear motion andre motion of a body along a straight line is called rectilinear motion. Okay, so our interest in this chapter is motion along straight line. Usually adana enanta word use martivi, rectilinear motion anta karitivi. Okay, motion of a body along a straight line, we call it as rectilinear motion. Okay, so this is one more new word, so you have to add to your vocabularies. Okay, So rectilinear motion. Okay, so what do you mean by rectilinear motion? So the motion of the object along a straight line, or motion in one dimension. We can simply use the word like one dimension. Okay, so only one coordinate of the particle is changing. Either x coordinate is changing, or y coordinate is changing, z coordinate is changing. Any one, not all 2 or 3. Okay, so that is your rectilinear motion. Example yavadu? A car moving along a straight line, a freely falling body. Okay, so if a car is restricted to move along a straight line, so that is one example for rectilinear motion. So don't imagine the normal vehicle movement, because there it's more or less going to be a two-dimensional motion. Okay, it's not just one direction. Okay, it's x and y, both coordinate will be changing. But if we restrict the track, okay, to go in one particular direction, so that can be considered as a rectilinear motion. The other one is the best example, the real time best example, that is freely falling body. Just imagine that you are dropping a stone from some height, or you are dropping a ball from some height. So enagattavaga, yeah, it just falls in a vertical line, right? So it just falls down. So that is a definite real time example for motion in one dimension. Okay, is that clear? Shall we move ahead? Hope all of you are with me now in following this session. Just give me a thumbs up or respond to me in chat box that you're following and understood till here. These are all the very basic definitions. I'm just waiting for your response in chat box. So if you understood, just give me a thumbs up, or you can like the video as well. Okay. So next, the other quantity which you have to define here is scalar quantity. Okay, so this you might be little familiar now. You may have defined all this in your colleges as well. So scalar quantity andre the physical quantity having only magnitude. Okay, the quantities which are having only magnitude, we call them as scalar quantity. Okay, so example yavadu? Mass, length, time, current, temperature, so on. Okay, similarly we are having the other type of physical quantity which we call it as vector quantity. They are going to have both magnitude and direction. Okay, both magnitude and direction idre adana ನಾವು vector quantity ಅಂತ ಕರಿತೀವಿ. So example yavadu? Velocity, acceleration, force, torque, etc. Okay, so if the physical quantity only magnitude idre scalars, magnitude ಜೊತೆಗೆ direction define ಮಾಡಿದ್ರೆ, if the direction is also important, then we call them as vector quantities. Okay, so any doubt, please ask in chat box. I'm not getting any response here now. Hope you're following and understanding. Okay, so we'll just move ahead to next concept, that is position, path length and displacement. Okay, again these three are three important parameters which we need to know before defining velocity and acceleration in case of any type of motion, whether it is motion in one dimension or two dimension or three dimension. So how to specify the position of the object, okay, in the case of motion? Heng helbodu? So it is, if we want to see the position of object at any instant of time, okay, it is the distance of the object from the origin of the frame of reference. So ಇಲ್ಲಿ important in order to specify the motion of a particle, okay, we definitely need to have something called as frame of reference. So ಇಲ್ಲಿ frame of reference andre ಬೇರೆ ಇನ್ನೇನು ಅಲ್ಲ. So it is just the coordinate axis, what we call it as XYZ coordinate axis. Okay, So let me just draw the coordinate axis. So it's just our coordinate axis, three-dimensional coordinate axis. I'm just taking for reference, okay? But here we are not talking about the three-dimensional motion, okay? Yeah. So we can say x-axis, y-axis, z-axis. So the coordinate axis and where these three axes are, meeting, we call that point as origin O, okay? So usually in our motion, we consider the starting point itself as origin. So that makes our problem solving very easy, okay? Or, discussing about that particular, type of motion will become easy if we choose our starting point itself as origin. Most of the case we do that, okay? Yeah. And along with this, we need to measure the time. We need to have a clock so that I can measure the time, or I can see as the time passes what is the position of the particle and all, so I can measure it, okay? So three coordinate axes along with the time measurement is going to give us something called as frame of reference, okay? With respect to this frame of reference, okay, whether the object position is at what coordinate, okay, so that is going to describe the position of the object. ಹೆಂಗೆ ಹೇಳ್ಬೋದು, position of the object at any instant of time is the distance of the object from the origin. So for example, if I say the particle is here, okay, so its distance from the origin, some coordinate we get x, y, z coordinate, okay, so it is going to give us the position of the particle, okay? So one dimension adre very easy, right? So we will have just like x-axis or y-axis. So this will be our negative x-axis. Let me say this is our origin, okay? So the particle may be present somewhere here. One dimension idre easy, correct? So what is its distance? So if we measure, we are going to get the distance of this particle from the origin is going to give us the position, okay? So that's how we do the measurement of position. Hope it is clear. If you are there, please respond yes. Yeah. So the next thing is path length. So path length or distance traveled antanu heltivi, okay? Some of us will use the word like path length, some of you may use the word like distance. So it's just the a scalar quantity. Distance traveled is a scalar quantity. Our path length is a scalar quantity, which is nothing but it is the distance between the initial and final position. The actual distance traveled from its initial position to final position, we call it as path length, okay? So path length andrenu, it is the distance between the actual distance traveled between the initial and final position, okay? And as I already told you, it's a scalar quantity and it is always a positive value, okay? Path length is always going to be a positive value. So hege example tagolbodu. For example, let me say some person, okay, so it's starting initially when time t is equals to 0, he started from this position, let us assume, okay? He walks through some distance, let me say 500 meter walk madda anta helana, okay? This person has walked 500 meter till here. Let me say this is O, this is A. Next time ಮಾಡ್ತಾನೆ, he will come back in this direction, okay? So he will come back in the reverse direction. So again ಎಷ್ಟು ಬಂದಿರ್ತಾನೆ, ಅವನು ಟ್ರಾವೆಲ್ ಮಾಡಿರ್ತಾನೆ, again 500 meter ಬರ್ತಾನೆ in the ulta direction to come back to his initial position, okay? As I said, our starting position ನಾನು origin ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. So now if I ask you what is the path length in this case, can someone respond in the chat box? Path length ಏನಾಗತ್ತೆ ಈ ಕೇಸಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ, so going from O to A and then back to O again. So what is the total path length from this person? Can someone respond? Yes, hi, good evening. Hope you're following the session. You can name yourself properly so that I can take your name instead of calling you as some XYZ. Yes, Shrikant, you said it as 0. Okay, let me just wait for few seconds if I get any other different answer. Yes, Tanu, very good. It is 1000 meters. Unit is also very important. Okay, so in physics, you had to mention everything, every physical quantity along with the unit. So ಏನಾಗುತ್ತೆ ನೀವು ಯಾವುದೋ ಒಂದು 5 ಮಾರ್ಕ್ಸ್ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿರ್ತೀರಾ, ಫೈನಲ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಯೂನಿಟ್ ಮರಿತೀರಾ, 1 ಮಾರ್ಕ್ ಹೋಗತ್ತೆ, ಸರಿನಾ? ಸೊ ಯೂನಿಟ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಅದನ್ನೆಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಇಂದಾನೆ ನೀವು ಅಭ್ಯಾಸ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಯೂನಿಟ್ ಬರೆಯೋದು, ಗ್ರಾಫ್ ಹಾಕೋದು, ಲೇಬಲ್ ಮಾಡೋದು. ಎಸ್ ಸಾನ್ವಿ, ವೆರಿ ಗುಡ್. ಯಾ, so somebody has said like 1000 and I think they removed that chat as well. Anyway, so here what I was trying to tell you is yes, I think Shrikant, you also have to follow now. Here the point is path length, I said it as a scalar quantity. ಅಂದ್ರೇನು, ಡೈರೆಕ್ಷನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ. ಸೊ ಏನ್ ಮಾಡ್ತೀವಿ, ಡೈರೆಕ್ಷನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ ಅಂದ್ರೆ, ಸೊ ಐ ಸೇ 500 ಮೀಟರ್ ಇನ್ ದಿಸ್ ಡಿರೆಕ್ಷನ್ and 500 meter in this direction, totally ಎಷ್ಟಾಗುತ್ತೆ? ಡೈರೆಕ್ಷನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ ಅಂದಮೇಲೆ ನೀವು just you are going to add them without taking any plus minus there. Okay, 500 plus 500 which is going to give us 1000 meters ಆಗುತ್ತೆ. Okay, so if it was a vector like displacement, then your answer would be 0. Okay, is that clear? Yeah, hope you're there. Yes, Shrikant, hope it is clear. Yeah, as it is a scalar quantity, we are just going to measure what is the total distance traveled from initial position to final position. Okay, without considering the direction. Yes, okay, so that is going to be your 1000 meters. Okay, so moving to next concept, that is displacement. Slight different concept it is. So what is displacement? It is the change in position of a body in a particular direction is called the displacement of a body, or the easy way to remember the definition for displacement is that it is the shortest distance between initial and final position. So displacement andre it's a vector quantity, andre illi direction important. Okay, so if I'm talking about change in the position of a body in particular direction, so that is going to be displacement, or you can say it is the shortest distance between the initial and final position. So we can say initially the object is at some position like x1 and finally it is at some position like x2. Then what is the displacement anta kelidre en heltira? So this delta x is representing us the displacement. Okay, so displacement delta x will be equal to x2 minus x1 ಮಾಡಬೇಕು. Okay, so for example, again if I take the previous one kind of an example, so let us say this is some person who is standing at the origin. He walks for some 500 meter. Okay, and then he moves in this direction for some 200 meter, let me say. Okay, and then again he walks for some 300 meter from this position. Okay, let me say A, then B, and from B he reached a point C. So ಈಗ total displacement ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ರೆ, can someone answer now? Yeah, hope you can answer. Total displacement ಎಷ್ಟಾಗತ್ತೆ? Or okay, we can forget the presence of this that from B to C na we can ignore for now, let us say, instead of giving you a complicated situation. 1000 henge displacement I'm asking, not the distance traveled. So displacement andre enagutte, final position minus initial position alva. So first O to A displacement eshtiದೆ, it is clear, 500 -0 ಅಂತ ಬರೆದ್ರೆ 500 ಮೀಟರೇ ಆಗತ್ತೆ. ಕರೆಕ್ಟಾ? ಸೊ ನೆಕ್ಸ್ಟ್ A to B ತಗೊಂಡ್ರೆ ಏನಾಗತ್ತೆ? A to B ಅಲ್ಲಿ ಸೊ ಇಲ್ಲಿ 500 ಇದೆ, -200 ಮಾಡಿದ್ರೆ ಎಲ್ಲಿಗೆ ಬರ್ತೀನಿ ನಾನು? 300 ಮೀಟರಿಗೆ ಬರ್ತೀನಿ. ಕರೆಕ್ಟ್? ಸೊ ಇನ್ ದಿ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್. ಯಾ, ಸೊ ದಟ್ಸ್ ವೈ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಓಕೆ, ಸೊ ಈಗ ಫೈನಲ್ ಪೊಸಿಷನ್ ಏನಾಗಿರುತ್ತೆ? ಇಫ್ ಐ ಜಸ್ಟ್ ಸಿ ಫ್ರಮ್ O to B, O to A and then back to B, OAB displacement ನೋಡಿದ್ರೆ ಏನಾಗಿರುತ್ತೆ? So that will be like, final position is this one, no? This is my final position. That is, I will be at a position of 300 meter. So initial minus final, only this distance I have to take. So from where to where? This will be my displacement, 300 meters. Okay. Yeah, 300 meters is going to be my displacement for the journey between O to A and back to B. Again, from B ಇಂದ C ಹೋಗಿರೋದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? O to A and then B and then C. If I consider this whole motion, so illénagirutte? So here my initial position is 300 and then further 300 in this direction. Correct? Are you following? Yes or no? Yeah. So whenever we are talking about the displacement, direction is important. Yes. Okay, whenever we are talking about the displacement, which is a vector quantity, direction is essentially important. Okay, so illenagatte so from B to C, if I say, okay, I am at a position like my initial position is 300 meter. Correct? I can say x1 is 300 meter. Okay, and x2 is, I have added 300 to it, right? So my position will be, this will be 600 meter kind of a thing. Yes or no? Yeah. So x2 is 600 meter. So total displacement enagatte? Yeah. So that is 600 minus 300, which is just going to be 300 meters. Is that clear? Yeah. So whenever we are talking about the displacement, we have to consider the direction. Okay, so or the easy way is to take one direction as positive, whichever is in this direction you take it as negative. Okay, corresponding position na tagoli, x2 minus x1 madi. So always take one direction as positive, other direction as negative whenever you are calculating the displacement. Okay, hope it is clear. I think I can go ahead. Yeah. So the next thing is, this is one special case where the displacement will be equal to the distance traveled when the body moves in straight line or in one direction. Okay, if the body is, as long as, if as like our previous example, okay, not even in this. So let me just say, if the person is traveling, okay, so starting from O, he travels only in this direction. There is no direction reversal. Okay, so let us say the person is just traveling in one direction without changing its direction of motion. Okay, so let me say somewhere around 500 meter again. Okay, so ee case alli if he just travels from O to A, so illi enagirutte, distance will be equal to displacement agirutte. The actual distance traveled will be equal to displacement. Okay, so if the motion is only along one particular direction without changing the direction of motion, so then we can say that the distance traveled will be same as your displacement. Okay, so hope we can go ahead quickly. one response in the chat box, please. Yeah. Okay, so moving ahead. Yeah, so now coming to the concept of velocity. So what is velocity? So as we said, if the object is in motion, we definitely see its position is changing. Then I can find out the displacement as well as the distance traveled, correct? So displacement andre en martivi, final position minus initial position we will do. Okay, so in that case, okay, so enagirutte, maybe throughout that motion, at what speed or at what rate the object is moving. So our quantity na now velocity anta karitive. Okay, so at what, how fast the object is moving or how slow the object is moving. So that is what is your velocity. Okay, so velocity alli ಎರಡು type of velocity define ಮಾಡಬಹುದು. ಒಂದು average velocity. Okay, so the average velocity of an object is the ratio of the displacement to the corresponding time interval. So average velocity hege define ಮಾಡಬಹುದು. So let me say V average. So it's a vector quantity. I think you know the notation. We should put an arrow on that just to keep that habit. I'm just using the notation here itself. So average andrenu, sorry, vector andrenu. So on top of the variable you have to put a arrow. Okay, so ಇಲ್ಲಿ average velocity ಹೇಗೆ define ಮಾಡಬಹುದು? This is like total displacement by the corresponding time interval. Okay, total displacement by the corresponding time interval. So ಈಗ okay, ಇಲ್ಲೇನಾಗಿರುತ್ತೆ, displacement andre we know something like x2 minus x1 by the time interval delta t anta ತಗೊಳ್ಬಹುದು, or this x2 minus x1 is nothing but delta x anta use ಮಾಡ್ತೀವಿ notation. So delta x by delta t is going to be your average velocity. Okay, the displacement corresponding to the given time interval, if you take that ratio, that is going to give you the average velocity. Okay, so that is our average velocity. Okay, hope you're following. Okay, so the next thing is, what might be the unit of velocity? Displacement by time kind of a thing, right? So we can say the SI unit for this will be meter per second or meter second minus 1 anta ತಗೊಳ್ಬಹುದು. Okay, so this is how we define average velocity. So the next thing which is very important is instantaneous velocity, or generally velocity antanu karitivi. Unless they say or specify as average or something, we are just talking about the velocity at the given instant. That is your instantaneous velocity. Okay, the instantaneous velocity or simply velocity is given by the limiting value of the average velocity as the time interval become infinitesimally small. Okay, so it's the limiting value of the average velocity. Okay, instantaneous value or instantaneous velocity andre it is the limiting value of the average velocity. So illi there is a calculus notation which you learn in your mathematics. Differentiation start agidre you might have studied this. So limiting value andre heng baritivi, it is nothing but illi yava idana we are making it to 0, time interval na small ಮಾಡ್ತಾ ಇದೀವಿ. Time intervals becoming infinitesimally small and as small as possible anta. It is like very close to 0 but not equal to 0. That is what your delta t tending to 0 notation ideyalla. So that means, yeah, we are going to have t as close as 0, the delta t as close as 0 but not equal to 0. Okay, so that is our the meaning of infinitesimally small or limiting value. Okay, so notation henge baribodu. So the instantaneous velocity v is equals to limit delta t tending to 0 andre time interval na small ಮಾಡ್ತಾ ಇದೀವಿ. Okay, so delta t tending to 0 of average velocity. Average velocity ಏನು ಫಾರ್ಮುಲಾ ಬಂದಿದೆ ನಮಗೆ? delta x by delta t anta bandide. So this is nothing but equal to dx by dt. So idanna ನಾವು maths ಅಲ್ಲಿ we call it as differentiation or derivative of x with respect to time. Okay, so v is equals to dx by dt. So velocity is dx by dt ಆಗುತ್ತೆ. Okay, hope you are following. Any doubts? Yes, hello. What's your name? How to pronounce? Tahseen. Hello. Hope you are following the session. And if you have any doubts, please ask in the chat box. Okay. So, illi, just to give you a graphical representation of what we are talking. So, let me say I have some, x with t, let me say. Okay. Some object is under motion. So, it might be going something like this. So, illa en madana, initially some time interval choose ಮಾಡ್ತೀನಿ. This is t1 and this is t2. ಎರಡು time interval na choose ಮಾಡ್ತೀನಿ. Okay. So, initially the particle was somewhere here. Okay. After some time it is here. So, ಈಗ we will say some position like x1 and x2. Okay. So, ಈಗ displacement ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ x2 minus x1, correct? Displacement will be the shortest distance, that is x2 minus x1. So, ಈಗ I can define average, correct? V average is x2 minus x1 by t2 minus t1 ಆಗಿರುತ್ತೆ. Okay, so this is just going to give me the average velocity. And ಇದರ direction ಎಲ್ಲಿರುತ್ತೆ? Along the displacement direction, x2 minus x1 direction ಅಲ್ಲಿ ಇರುತ್ತೆ. Okay, so along the displacement direction irutte, average velocity direction. Okay, ಈಗ ಏನು ಮಾಡೋಣ, we will bring this t2 as close as possible to t1. That is our job. ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, or we can also say we can bring t1 and t2 close to each other. Okay, interval small ಮಾಡ್ತಾ ಹೋಗಬೇಕು. delta t is tending to 0 ಅಂದ್ರೆ ಏನು, ಈ interval ನ small ಮಾಡ್ತಾ ಹೋಗಬೇಕು. So at some point of time, okay, so e line ಏನidella, this delta x line, so that becomes tangent at this point. Okay, so let me call that point as some p, and okay, yeah, so that is what our instantaneous velocity. Okay, okay, so here what we are having is we try to do delta t as small as possible. Okay, so that this limit as delta t tending to 0 of delta x by delta t will become dx by dt. So dx by dt andre it is nothing but tangent at that point ಆಗಿರುತ್ತೆ. Tangent at that point. Okay, so that is the geometrical meaning of your dx by dt. So dx by dt andre you will be plotting a tangent to the given curve. Okay, so this is how you define instantaneous velocity. Again, instantaneous velocity alli unit enu meter per second ಆಗಿರುತ್ತೆ, because dx has a unit like displacement, meter is the unit, and dt is our time interval, so which is second. So dx by dt andre meter per second unit ಆಗಿರುತ್ತೆ. Okay, again this is also a vector quantity. This is a vector quantity with a unit of meter per second. Okay, hope you understood how to get the average velocity and instantaneous velocity. Is that clear? Any doubt? Please ask in chat box. Let me just check once. Yeah, instead of chatting something else, you can pay attention to the class and you can ask some genuine doubts if you have, to whoever is dropping some unnecessary comments in the chat box. Yeah, please follow the session and ask genuine doubts. Okay. Yeah, hope that is clear. Any doubts? I'll be just waiting for your doubts in the chat box, academic related doubts. Okay. So now, as I just said, when we make, the time interval as small as possible, we end up with a notation of dx by dt, which is, geometrically, it's nothing but the tangent at that point, slope of the tangent at that point. Okay. And also we can say it is the rate of change of position at that time, dx by dt. Any notation like d by dt, if I have a notation like d by dt, it is like rate of change of. Illi time idre time rate of change of anta. Time rate of change of. Okay, ade kelagade x idre d by dx idre, yeah, displacement rate of change of. Okay, it is the rate of change of anta. D by dt, your differentiation notation is nothing but rate of change of some quantity with respect to some variable. That is what is the meaning of dx by dt. Okay. Yeah. So as I said here, dx by dt is the rate of change of position of the particle at that time agirodrinda. If I want velocity or the instantaneous velocity, if I know the position of the particle, how it is changing with time, then I can just get the velocity. So for that, one simple problem is there that we will take up. Okay. And before that, there is one more definition, that is instantaneous speed. So the speed is a scalar quantity. Okay, if we just take the magnitude of the velocity, that is going to give us the instantaneous speed. Okay, speed andre scalar quantity. We are just talking, or we are just considering the magnitude of the instantaneous velocity. That is going to give us the instantaneous speed. Okay, and instantaneous means what? At a given instant anta artha. Okay, instantaneous andre in meaning in general. So let me just write here, at a given time. It is like the time which is of our interest at this given time. It's like, might be at 3 seconds, might be at 4 seconds, 5 seconds. At that given interval of time, what is its velocity? Okay, so that is the meaning of instantaneous velocity. Adhe tara instantaneous speed bekandre en martira, just consider the magnitude of the instantaneous velocity. Okay, matte speed in a unit meter per second irutte, unit en change agalla. Hope it is clear. Any doubts? Please ask. If you have any doubts, please ask in the chat box. Okay. So here is the question. The position of an object moving along x-axis is given by x is equals to a plus b into t square, where a is equals to 8.5 meter and b is equals to 2.5 meter per second square, and t is measured in second. What is the velocity at t is equals to 0 and at t is equals to 2 seconds? Okay, so this type of simple problem can be asked in 2 or 3 marks question. This is just to make sure that you will become familiar with the formula v is equals to dx by dt. Formula nimge familiar agli anta ee problem tagondidini. Okay, it's a simple problem from your NCERT itself. So v is equals to dx by dt. So en kelidare velocity kelidare, and we are given with the position of the particle as a function of time. So velocity beku andre differentiate the position. Okay, that's all is the simple rule. So en mana v is equals to d by dt of a plus b into t square. Okay, v is equals to d by dt andre differentiate x with respect to time. So illi x andre enanta substitute ಮಾಡಬಹುದು, a plus b into t square. Okay, so ಈಗ differentiation of a with time ಏನಾಗುತ್ತೆ, differentiation of a constant is always 0. Please remember, you might have been given with some basic formulas of differentiation. If not, I'll just keep on giving as we are going ahead. So differentiation of a constant is 0. Please remember. Okay, differentiation of a constant is always 0. So illi idana split ಮಾಡಿ ಬರೆಯೋಣ. Just as we are doing it for the first time, I am writing each and every step. dA by dt plus d by dt of second term ಏನಿದೆ b into t square. Okay, or ಈಗ differentiate ಮಾಡಿದ್ರೆ, so this is the differentiation of a constant ಇರೋದ್ರಿಂದ this term goes to 0. Now our job is to differentiate b into t square. Okay, so ಈಗ I'll just write the formula in the next page. So ಏನಾಗಿರುತ್ತೆ, d by dt of x raised to n ಇದ್ರೆ, differentiation of x raised to n ಇದ್ರೆ, okay, or 1 second, t raised to n ತಗೋತೀನಿ ಇಲ್ಲಿ. Okay, so ಅದರ differentiation formula ಏನಿರುತ್ತೆ, so formula says us that n into t raised to n minus 1, or you might have learnt with the notation of d by dx of x raised to n idre n into x raised to n minus 1 anta kaltirtira. Okay, so this is the differentiation formula for x raised to n or t raised to n. So ega if we have some constant along with this t raised to n, so illi a antide ankoli, a illi barutte ashte. Okay, along with the constant, if you have a variable aga 0 agalla. Okay, full constant term idre, okay, there is no time dependent term here. First term alli enagide, d by dt of a anta ide, a is a full constant, value ne kottbittidare 8.5 anta alva, it has no time dependency. Aga enagatte differentiation 0 agutte. Ade time dependent term idre we had to differentiate it. Okay, so adara coefficient will keep constant, I mean as it is, that is b antide. So ಈಗ t square ನ differentiate ಮಾಡಬೇಕು. t square differentiation ಏನಾಗುತ್ತೆ, if you just check with our formula, ಈ formula ಹಾಕ್ತೀನಿ, d by dt of t square. ಸೊ ಇಲ್ಲಿ n ಅಂದ್ರೆ ಏನಿದೆ ನಮಗೆ 2 ಇದೆ. ಸೊ ಏನಾಗುತ್ತೆ ಆಗ 2 into t raised to 2 minus 1, which is nothing but equal to 2t ಆಗುತ್ತೆ. ಕರೆಕ್ಟಾ? ಯಾ, ಸೊ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ, 2t ಬರುತ್ತೆ. differentiation of t square is 2t. okay, so ಇಲ್ಲಿ ಏನು ಬರುತ್ತೆ ನಮಗೆ 2t, or I can just write like 2b into t. okay, so this is the velocity at any time. ಆಯ್ತು, ಈಗ ನಮಗೆ ಏನು ಬೇಕು, we had to find out the velocity at time t is equals to 0 and at time t equals to 2 seconds ಅಂತ ಇದೆ. ಕರೆಕ್ಟಾ? ಸೊ this will keep as formula. So I'll just put aside in a bracket. So we'll continue with the problem there. So ಏನು ಬಂತು ನಮಗೆ, velocity v is equals to 2bt ಅಂತ ಬಂದಿದೆ. ಈಗ at t is equals to 0 ಮಾಡಿದ್ರೆ I get velocity as 0 itself, because 0 into anything, ಇಲ್ಲಿ time ಗೆ 0 substitute ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, so 0 into anything is going to give us 0. and ಇನ್ನೊಂದು ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, at t is equals to 2 I think 2 seconds alva, yeah, at t is equals to 2 seconds ಇನ್ನೊಂದು ಕೊಟ್ಟಿರೋದು. okay, at t is equals to 2 seconds. so velocity ಏನಾಗುತ್ತೆ, 2 into b into 2 seconds, or so 2 into ಇಲ್ಲಿ b value ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಷ್ಟಿದೆ, b value is given as 2.5, ಅದನ್ನು substitute ಮಾಡೋಣ. 2 into 2.5 into 2, or this is going to give us 10, correct, 10 meter per second agate. Yeah, hope you are following. Yeah, any doubts? You can just raise your doubts in the chat box. Yeah. So this is one method to find out the velocity of a particle when position of the particle is given to you. Okay, velocity is dx by dt. Okay, is that clear? Hope we can go ahead. Just respond once in chat box. Okay, I think we can go ahead. Yeah, so the next concept is to define acceleration. Okay, so again illu ಎರಡು type of acceleration define ಮಾಡ್ತೀವಿ. ಒಂದು average acceleration and the other one is instantaneous acceleration. Okay, so average acceleration ಅಂದ್ರೇನು? It is the change of velocity divided by the time interval. Okay, so just like as we have defined our velocity, average velocity, so average acceleration can be given by change in velocity, that is like v2 minus v1 by t2 minus t1, or initial time na 0 anta assume madirthivi most of the time, or this can be written as delta v by delta t. Okay, so delta v by delta t agirutte. So direction of average acceleration will be along delta v. Okay, yes Prarthana. Okay, you can nothing to worry, you can just follow the session from this point. Okay, yeah, so we just have discussed about the concept of position, displacement, velocity and their representation, and one simple problem we have worked out which you can refer to it later. And now we are we are defining what is acceleration. So in that we have average acceleration, which is the change in velocity to the corresponding time interval, and we can write down the unit. So unit ಏನಾಗಿರುತ್ತೆ? So ಇಲ್ಲಿ change in velocity ಅಂತಿದೆ. Velocity unit is meter per second divided by second ಆಗುತ್ತೆ. So we can say like meter per second square or meter second minus 2. Okay, so that will be the unit of average acceleration. And again, this is also a vector quantity. Remember, acceleration, velocity, displacement are going to be vector quantity. Okay, so again we are trying to define instantaneous acceleration just as we did for velocity. Allen madidvi, the limiting value of the average velocity was giving us the instantaneous velocity. Similarly, we are doing instantaneous acceleration is the limiting value of the average acceleration as the time interval approaches 0. Andre ಏನು ಮಾಡ್ತೀವಿ? Delta t tending to 0. Okay, time duration smaller and smaller. ಈ denominator ಏನಿದೆಲ್ಲ t2 minus t1, so ಅದನ್ನ smaller and smaller ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. We never made it equal to 0, but as small as possible ಮಾಡಿದ್ರೆ we get the acceleration of the particle at that time ಆಗಿರುತ್ತೆ. So if I had to write it in the notation, so acceleration is or the instantaneous acceleration, or in general acceleration andre instantaneous acceleration we will be talking. Okay, it's the acceleration at the given instant of time will be equal to limit as delta t tending to 0 delta v by delta t, or by calculus this is nothing but equal to dv by dt ಆಗಿರುತ್ತೆ, rate of change of velocity. Okay, rate of change of velocity. As I just told you, d by dt andre rate of change anta. Illi enide velocity ide ashte. So rate of change of velocity is nothing but your acceleration. So nimige velocity kottiddu acceleration beku andre ಏನು ಮಾಡಬೇಕು? Just to differentiate it once with respect to time, you get the acceleration. Yes, hope you are following. Yeah, any doubts please ask in the chat box. Okay, so the next point is acceleration at an instant is the slope of the tangent to the vt curve at that instant. So this is also very similar to what we learned for velocity. So velocity alli enagittu, yeah, I said this dx by dt is nothing but the tangent anta helde alva. Tangent to the position time graph will give us velocity. Similarly, if you plot vt graph, okay, so velocity with time graph plot madidri anta ankolona, some kind of velocity ide, need not be straight line and all. So ee case alli enagutte, yeah, if I want acceleration at this point, okay, draw a tangent, okay, and slope of that tangent will give us the acceleration at that particular point. ಓಕೆ, ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಇನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟು ಆಕ್ಸಲರೇಷನ್ ಇದೆ ಅನ್ನೋದು ಬೇಕು ಅಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕು, ವಿ ಟಿ ಗ್ರಾಫಿಗೆ ನೀವು ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡಬೇಕು. ಓಕೆ, ಹೋಪ್ ಇಟ್ ಇಸ್ ಕ್ಲಿಯರ್. ವಿ ಕ್ಯಾನ್ ಗೋ ಅಹೆಡ್, ಐ ಗೆಸ್. So now we are moving to something called as the graphs in kinematic or kinematics. Okay, so there are several graphs we plot. In that there are two important graphs which you have to understand. One is position time graph and the next one is velocity time graph for different situation. Okay, different situation andre one case alli velocity increase ಆಗ್ತಿರಬಹುದು, ಇನ್ನೊಂದು ಕೇಸ್ ಅಲ್ಲಿ velocity decrease ಆಗ್ತಿರಬಹುದು, ಇನ್ನೊಂದು ಕೇಸ್ ಅಲ್ಲಿ velocity constant ಇರಬಹುದು, or the object might be moving in positive x-axis, negative x-axis. So depending on that we had to plot the position time graph. So illi these can come in 2 marks. Any graph can be asked for 2 marks. Okay, and the ಎರಡ್ graph ಕೇಳ್ತಾರೆ usually. Okay, so draw position time graph or velocity time graph for these two given situation. So 2 mark question ಇರುತ್ತೆ. Okay, so ಇಲ್ಲಿ 3 different case consider ಮಾಡಿದೀವಿ. First case ಅಲ್ಲಿ ಏನಿದೆ, yeah, we have position on x-axis, position on y-axis and time on x-axis. That is very important. So to note, so ಏನು ಮಾಡಿರ್ತೀವಿ position time graph ಅಲ್ಲಿ position na y axis ಅಲ್ಲಿ plot ಮಾಡಿರ್ತೀವಿ and time is on x axis. Okay, so first case ಅಲ್ಲಿ positive acceleration ಇದೆ. Okay, if they tell you to draw position time graph for the curve, for the case where acceleration is positive. Okay, positive acceleration ಅಂದ್ರೆ acceleration some constant value ಇದೆ, but some positive value ಇದೆ ಅಂತ. Okay, so in that case you are going to have a curve like this. Okay, yeah, that is a graph curves upward for positive acceleration. Similarly, if acceleration is negative, some constant negative value ಇದೆ, acceleration is some constant negative value ಇದ್ರೆ ಆ ಕೇಸ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಗ್ರಾಫ್ will be curved downward to x axis ಆಗಿರುತ್ತೆ. Okay, and then it is a straight line for zero acceleration. ಈ zero acceleration ಅನ್ನು ಏನಂತ ಕರಿತೀವಿ, so that is nothing but uniform motion. Uniform motion. Okay, so this is uniform motion. Acceleration zero andre velocity constant. Okay, I can also say this corresponds to v constant. And we know that acceleration is dv by dt. Differentiation of constant is 0. That is what we are saying here. Acceleration 0 andre velocity constant irlebeku. Okay, hope it is clear. So moving to next graph, position time graph, an object moving with positive velocity. Okay, position time graph for an object. Okay, position time graph for an object moving with positive velocity. ಈ ಕೇಸಲ್ಲಿ positive velocity ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ and we are assuming like acceleration is 0. Okay, ಏನು ಅನ್ಕೊಂತಾ ಇದೀವಿ, we are assuming like acceleration as 0. Okay, ಈ ಕೇಸಲ್ಲಿ acceleration 0 ಇದೆ, some constant positive velocity ಇದೆ. So in that case we will get a straight line. Okay, we will get a straight line. Position time graph ಏನಾಗಿರುತ್ತೆ, straight line ಆಗಿರುತ್ತೆ. Okay, So next is position time graph moving with negative velocity. If velocity is negative, okay, so ಆಗ ಏನಾಗಿರುತ್ತೆ, position time graph is going to have a negative slope, negative constant slope. Again ಈ ಕೇಸಲ್ಲಿ we are considering A0. Okay, so these are all position time graph. Is that clear? Okay, so it has some constant negative velocity. Okay, so that's why we are having a negative slope here. This is a positive slope. Okay, so you should be very clear. If they just mention about velocity instead of mentioning acceleration, you have to make sure that whether it is a accelerated or non-accelerated. So non-accelerated motion andre uniform motion. Okay, so acceleration 0 andre uniform motion anta karitivi. Okay, acceleration 0 irutte, velocity constant irutte. Okay, so this is one graph. The other type of graph that will be asked is velocity time graph. Again, this is also important for 2 mark. So ಇಲ್ಲಿ ಏನು ಮಾಡಿರ್ತೀವಿ, velocity along y axis plot ಮಾಡ್ತೀವಿ, velocity along y axis and time along x axis plot ಮಾಡಿರ್ತೀವಿ. Okay, so you had to label the axis. Y axis ಅಲ್ಲಿ v ಅಂತ ಬರಿಬೇಕು, x axis ಅಲ್ಲಿ t ಅಂತ ಬರಿಬೇಕು. That is labeling in the graph. Okay, then only you get marks. You should know velocity along y axis and time along x axis plot ಮಾಡಿದ್ರೆ ಆ ಗ್ರಾಫ್ ನ ನಾವು velocity time graph ಅಂತ ಕರಿತೀವಿ. Okay, again any two graph they may ask for 2 marks. Okay, so first case ಏನು ತಗೊಂಡಿದ್ದೀವಿ ಇಲ್ಲಿ, an object is moving in a positive direction with a positive constant acceleration. So in this chapter, okay, we are sticking ourselves to constant accelerated motion or uniformly accelerated motion. So uniformly accelerated motion andre ನಿಮ್ಮ velocity time graph linear ಇರುತ್ತೆ. Okay, uniformly accelerated motion ನ ತಗೊಂಡ್ರೆ velocity time graph ಏನಿರುತ್ತೆ, straight line ಇರುತ್ತೆ. Non-uniform accelerated andre it need not to be straight line. VT graph can be of any shape. But ನಮ್ಮ ಡಿಸ್ಕಷನ್ ಅಲ್ಲಿ ಈ ಚಾಪ್ಟರ್ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇರೋದು ಯೂನಿಫಾರ್ಮ್ಲಿ ಆಕ್ಸಿಲರೇಟೆಡ್ ಮೋಷನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಏನಾಗಿರುತ್ತೆ ಆ ಕೇಸಲ್ಲಿ, we will be having straight line. Okay, VT graph will be straight line. So that the slope, that is dv by dt ಏನಾಗಿರುತ್ತೆ, constant ಇರುತ್ತೆ. Okay, dv by dt, the slope is going to be constant. Straight line ಗೆ slope ಏನಾಗಿರುತ್ತೆ, just find the tan theta ಅಲ್ವಾ, so that is going to be constant ಇರುತ್ತೆ. Okay, so this is one graph. So ಏನಾಗಿದೆ, some initial velocity, positive acceleration ಇರೋದ್ರಿಂದ ಏನಾಗಿದೆ, velocity increase ಆಗಿದೆ. As the time passes, velocity increase ಆಗಿದೆ. Okay, so the next one is an object is moving in positive direction with a constant negative acceleration. Object positive directional move ಆಗ್ತದೆ, like along positive x axis, but ಅದರ acceleration ಏನಿದೆ, negative acceleration ಇದೆ, constant negative acceleration. Okay, ಆಗ ಏನಾಗುತ್ತೆ, velocity decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ as time passes. Okay, velocity decreases as time passes. Okay, so that's the idea. So ಇಲ್ಲಿ velocity initially ಒಂದು constant strong value ಇದೆ, v naught ತರ some initial value, and as time passes velocity is decreasing linearly. Okay, so that is our graph for an object moving in positive direction with a constant negative acceleration. Okay, moving to the next graph. If we are having object is moving in negative direction, this is important. Object ಯಾವ direction ಅಲ್ಲಿ move ಆಗ್ತಾ ಇದೆ, negative direction, like minus x axis or minus y axis kind of a thing, and it is also having a negative constant acceleration. Acceleration negative ಇದೆ, object is also moving in the negative direction. So ಆಗ ಏನಾಗುತ್ತೆ, negative direction ಅಂದ್ರೆ ಇಲ್ಲಿ velocity negative ಇರುತ್ತೆ. Okay, velocity negative ಇರುತ್ತೆ. So as the object is moving in the negative direction and ಇಲ್ಲಿ ಏನಾಗಿದೆ, negative constant acceleration ಇರೋದ್ರಿಂದ, so as time passes velocity increases in the negative direction. Okay, so ಏನಾಗಿದೆ, velocity is increasing in the negative direction. Adru magnitude tagondre jaasti adang ansirutte, but if there is a minus, okay, so it is like -2 ide, -5 ide, which is bigger is -2 only, correct? Yeah, if we ignore their sign, then we say okay 5 is greater than 2, but ಏನಾಗಿದೆ, it is increasing in the negative direction. That's what I mean to say. Okay, as the time passes, velocity is increasing in the negative direction ಆಗಿರುತ್ತೆ. Okay, so this is another case, and one more case we can take, that is an object is moving in positive direction till t1. Okay, t1 ಅನ್ನೋ ಟೈಮ್ ತನಕ ಆಬ್ಜೆಕ್ಟ್ ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತದೆ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಏನಿರುತ್ತೆ, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ವೆಲಾಸಿಟಿ ಇರುತ್ತೆ. Okay, then turns back ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ, so if initially it was moving like this, I am assuming it has a positive direction, so next ಏನಾಗುತ್ತೆ, the object comes in this direction, so that is my negative direction, so velocity negative ಆಗುತ್ತೆ with the same negative acceleration. Okay, so negative acceleration ಅಂದ್ರೆ ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡಿ, ಏನಾಗಿರುತ್ತೆ, velocity decrease ಆಗಿರುತ್ತೆ. ಇಲ್ಲಿ negative acceleration ಅಂದ್ರೆ velocity decrease ಆಗುತ್ತೆ. ಓಕೆ, ಪಾಸಿಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಆಕ್ಸಿಲರೇಷನ್ ಕೊಟ್ಟಂಗೂ ಏನಾಗುತ್ತೆ, ವೆಹಿಕಲ್ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ತಾನೆ. ಸೊ ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್. ಓಕೆ, ಪಾಸಿಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅಂಡ್ ಇಲ್ಲಿ ಒಂದು ಸ್ಲೈಟ್ ಎಕ್ಸ್ಟ್ರಾ ಕಂಡೀಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇನಿಷಿಯಲಿ ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗಿರುತ್ತೆ ಅಪ್ ಟು ವಾಟ್ ಟೈಮ್, t1 ಅನ್ನೋ ತನಕ. ಆಫ್ಟರ್ ದಿ ಟೈಮ್ t1 ಇಟ್ ಇಸ್ ಚೇಂಜಿಂಗ್ ಇಟ್ಸ್ ಡಿರೆಕ್ಷನ್. ಸೊ ಏನಾಗಿರುತ್ತೆ, ವೆಲಾಸಿಟಿ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಅ ನೆಗೆಟಿವ್ ವೆಲಾಸಿಟಿ ಹಿಯರ್. ಓಕೆ, ಇನಿಷಿಯಲಿ ಪಾಸಿಟಿವ್ ವೆಲಾಸಿಟಿ ಬಟ್ ಇಟ್ ಇಸ್ ಡಿಕ್ರೀಸಿಂಗ್, ನೆಕ್ಸ್ಟ್ ನೆಗೆಟಿವ್ ವೆಲಾಸಿಟಿ ಡಿಕ್ರೀಸಿಂಗ್ ಇನ್ ದಟ್ ಆಕ್ಸಿಸ್ ಆರ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಇನ್ ದಿ ನೆಗೆಟಿವ್ ಡೈರೆಕ್ಷನ್ ಅಂತ ಹೇಳ್ಬೋದು. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ಸಮ್ with respect to velocity time graphs. Okay, any doubt till here? I think yes, Narasimha, we are actually planning for that only. So today we are discussing the second chapter. In the upcoming days you will be having third and fourth chapter discussion as well, along with the question practice. Okay, if you have checked our playlist, yesterday we have uploaded one practice question discussion of units and measurement. Okay, and in the next class you will get the practice question discussion from this chapter, that is motion in one dimension. Okay, Sarina, hope you follow all the sessions. Okay, ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. Hope it is clear. Okay, so going ahead, just a second. Yeah, there's another simple graph. This is actually a very simple case. A body moving with uniform velocity. Uniform velocity ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಹೇಳಿದೀನಿ, ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ. ಆಗ ಏನಾಗಿರುತ್ತೆ, ಆಕ್ಸಿಲರೇಷನ್ 0 ಇರುತ್ತೆ. ಸೊ ಈ ಕೇಸಿಗೆ ನೀವು ವಿ ಟಿ ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ, ಓಕೆ, ವೆಲಾಸಿಟಿ ವಿತ್ ಟೈಮ್ ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಸೊ ವೆಲಾಸಿಟಿ ಮಸ್ಟ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್, ಇಟ್ ಶುಡ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್. ಅರ್ಥ ಆಯ್ತಾ? ಆಕ್ಸಿಲರೇಷನ್ 0 ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್. ಆಕ್ಸಿಲರೇಷನ್ ಇದ್ರೆ ಮಾತ್ರ ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಅದೇ ನೆಗೆಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್ ಇದ್ರೆ ಸ್ಪೀಡ್ ಡಿಕ್ರೀಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಪ್ಲಾಟ್ ದಿ ಗ್ರಾಫ್. ಸೊ ಎನಿ ಗ್ರಾಫ್ ಕ್ಯಾನ್ ಬಿ ಆಸ್ಕ್ಡ್ ಇನ್ 2 marks. Okay, and these graphs are very important for your competitive exams as well. They can ask one question on a graph base. Okay, any graph can be asked. So you should learn practicing how to represent the given situation graphically. Is that clear? Yeah, I hope it is clear. Now we are coming to one important point which I am going to give you, that is the area under velocity time curve represents the displacement over a given interval of time. This is very very important. So ಏನು ಹೇಳ್ತಾ ಇದೀವಿ, if we find out the area under VT graph, previous ಯಾವುದೇ velocity time graph ತಗೊಳ್ಳಿ, ಓಕೆ, ಇದಿರ್ಲಿ So if you find out this area, okay, so that is going to give us the displacement of the particle in the given interval of time. So ee graph tagondre from 0 to t ee area consider madidre, that is going to give us the displacement. Okay, area under vt graph gives us displacement. Along with, you can also remember two factor, tangent to vt graph gives you acceleration. Okay, ade tara tangent to position time graph, so I'll write like xt graph, gives you velocity. Can remember this by their usual notation also, because acceleration andrenu dv by dt, velocity andrenu dx by dt, and we know that mathematically dx by dt and dv by dt represents the tangent, the slope of the tangent at that particular point agirutte. Okay, hope it is clear. No doubts, I guess. Yeah, so we can just go to the very important topic of this chapter, that is kinematic equations for uniformly accelerated motion. So this can be a 5-mark question. Okay, so basically there are 3 equations of motion which we use in one dimension. So our mooru equation anna we are going to derive now. Okay, all the 3 equations we are going to derive by graphically. Question na ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ರೀಡ್ ಮಾಡಬೇಕು. Sometimes exam ಅಲ್ಲಿ they may ask you obtain the kinematic equations for uniformly accelerated motion graphically anta kotre ee method follow ಮಾಡಬೇಕು. Okay, there is one more method, that is calculus method. Calculus method na usually 3 marks ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. So but please read the question carefully, whether by calculus method or graphical method. If they don't mention, it is your choice, you can do calculus or graphical method, but my suggestion is that be prepared for the graphical method. Okay, so most of the time they specify as graphical method. Okay, so that's the in point here. So I'll just do one small change in this graph. So this I'll just mark it as U. Okay, so let us understand what this graph is representing, and let us consider all our notations clear first. So we are considering an object or a body, okay, which is having initial velocity as u, initial velocity na u anta tagolli. Okay, so that is usual representation I take for initial velocity. If you are comfortable with the notation as v naught, that's your choice. You can take v naught or whatever you want, you take, but you have to specify what you are taking. I am taking u as my initial velocity at time t is equals to 0. Okay, and after some time t, so the velocity of the object I am taking it as v. ಅದನ್ನ usually final velocity ಅಂತ ತಗೊಂತೀವಿ for the given time interval. Okay, initial velocity u, final velocity v ಇದೆ ಯಾವಾಗ after some time t. and ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ question ಅಲ್ಲೇ ಏನಿದೆ, uniformly accelerated motion ಅಂತ ಇದೆ. the object is moving with constant acceleration a, constant acceleration ನ a ಅಂತ ತಗೋತೀನಿ. Okay, okay, hope it is clear. I am taking it as constant acceleration a. So ಈಗ by definition constant acceleration ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ, throughout the motion of the particle its acceleration is same, there is no change in its magnitude or direction, correct? Acceleration is remaining constant. So ಆ ಕೇಸ್ ಅಲ್ಲಿ ನೀವು average acceleration define ಮಾಡಿದ್ರು instantaneous acceleration define ಮಾಡಿದ್ರು ಸೇಮ್ ಇರುತ್ತೆ ಎರಡು, because throughout the motion of the particle acceleration same ಇರೋದ್ರಿಂದ average acceleration and our normal instantaneous acceleration ಸೇಮೇ ಇರುತ್ತೆ. ಸೊ ಫ್ರಮ್ ದಟ್ ಐ ಕ್ಯಾನ್ ಸೇ ಬೈ ಡೆಫಿನಿಷನ್ ಏನು ಹೇಳ್ಬೋದು, ಓಕೆ, ಸೊ ಏನು ಹೇಳ್ಬೋದು, ಆಕ್ಸಿಲರೇಷನ್ ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಚೇಂಜ್ ಇನ್ ವೆಲಾಸಿಟಿ ಅಲ್ವಾ, ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ಟಿ ಅಂತ ತಗೋತೀವಿ. ಈಗ ಇಲ್ಲಿ ಚೇಂಜ್ ಇನ್ ವೆಲಾಸಿಟಿ ಏನಾಗುತ್ತೆ, ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಮೈನಸ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ಬೈ ದಿ ಟೈಮ್ ಇಂಟರ್ವಲ್. ಕರೆಕ್ಟಾ? ಏನ್ ಬರಿಬೋದು, ಆಕ್ಸಿಲರೇಷನ್ A is equals to V minus U by T minus 0 ಅಂತ ಬರಿಬೋದು. ಕರೆಕ್ಟ್? Final velocity minus initial velocity will give me the change in velocity to the corresponding time interval T minus 0 ಆಗುತ್ತೆ. Hope you are following everyone. So one response in the chat box please. Yeah. Or this can be just rewritten as V minus U is equals to A into T ಆಗುತ್ತೆ, because T minus 0 is T itself and cross multiply ಮಾಡಿದ್ರೆ A into T ಆಗುತ್ತೆ. Or this will give us V is equals to U plus AT ಆಗುತ್ತೆ. Okay, V is equals to U plus AT. So this is first equation of motion. Okay, so let me call this as equation 1. V is equals to U plus AT. So one equation derive ಮಾಡಿದ್ವಿ, just two step ಅಷ್ಟೇ. ಏನು, by considering the definition of acceleration we are doing it. Change in velocity by change in time, corresponding values na substitute ಮಾಡಿ you get one equation. So next ಏನು, from the previous note point I can say, if I calculate the area under velocity time graph, I get the displacement of this particle. Correct? So ಈ particle ಇನ displacement ಏನಿದೆ, so it is like, you know, initially its velocity is u, which is marked here. So it has undergone, you know, a displacement till some time t, and a time interval alli velocity heng change agide, 0 to v reach agide. Correct? Yeah. So initially u ittu, not 0 to v, it is u to v reach agide. Correct? Over the time interval velocity enagide, u inda v agide. So ಆ graph ನಮ್ಗೆ ಇಲ್ಲಿದೆ. Okay, so the same diagram I have put here. So let me just mark this as U. Yeah. So again, we will just try to find out the area. Okay. So we know that displacement of the particle ಇಲ್ಲಿ x ಅಂತ ತಗೊಳ್ಳೋಣ, because we are assuming initially it is starting from x is equals to 0 to x is equals to some displacement ಆಗಿದೆ. ಸೊ ಆಗ displacement ಏನಾಗುತ್ತೆ, x minus 0 ನೇ ಬರಿತೀವಿ. So we can take simply like the displacement of the particle as x, and now this x will be equal to area under vt graph ಅಂತ ಬರಿಬೋದು, that is velocity time graph. So ಈಗ area under vt graph between the time interval 0 to t find out ಮಾಡ್ಬೇಕು ನಾವು. Okay, so area ಏನಾಗುತ್ತೆ, so this is our, you know, the vt curve. So ಇದರ ಒಳಗೆ how much area is enclosed by this line. Okay, so this whole thing, right, this whole thing. So ಅದನ್ನ ಏನ್ ಮಾಡಿದೀವಿ, we have split into two components or two, you know, geometrical shape, so that it is easy for us to understand. ಏನು ಹೇಳ್ಬೋದು, this total area under this line AB, okay, the total area under the line AB will be equal to, so I can say area of the rectangle AODC, ಬರಿಬೋದಾ, area of rectangle AODC plus area of triangle. Okay, let me just write the symbol notation for triangle. So area of triangle ACB. ಹೇಳ್ಬೋದಾ? So can someone respond to me in the chat box if you are following? So area of the rectangle plus area of the triangle ಅಂತ ಬರಿಬೋದು. So ಈಗ displacement x is equals to, so area of the rectangle ಅಂದ್ರೆ length into breadth ತರ ಮಾಡ್ತೀವಿ. So that is like OD. ಇಂಟು AO ಅಂತ ಬರಿಬೋದು, ಪ್ಲಸ್ ಏರಿಯಾ ಆಫ್ ದಿ ಟ್ರಯಾಂಗಲ್ ಇಸ್ ಹಾಫ್ ಇಂಟು ಬೇಸ್ ಅಂದ್ರೆ ಇಲ್ಲಿ AC ಆಗತ್ತೆ, ಹೈಟ್ ಅಂದ್ರೆ ಇಲ್ಲಿ BC ಆಗತ್ತೆ. ಈಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. OD ಅಂದ್ರೇನು? ದಿಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಟೈಮ್ T, ಕರೆಕ್ಟ್? ಸೊ ಅಲ್ಲೇನಾಗಿದೆ, ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಟೈಮ್ T, ಕರೆಕ್ಟಾ? So from here to here, this is nothing but T. So I can put that as T into AO andrenu. From here to here, it is initial velocity U, correct? Plus half into AC andre again, this is nothing but equal to OD agirutte, which is nothing but equal to T. So half into T into BC andre E length, correct? So from here to here length beku. So total till here final velocity V from here, correct? From O to this final point it is V. So from O to A it is U. So namige E length beku. Adenadu V minus U agirutte. So that is what it is, V minus U. Okay, our BC is equals to A and this point, correct? Yeah, so V minus U agirutte. Okay, so ಈಗ ಒಂದು ಸಿಂಪಲ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡೋಣ ಫ್ರಮ್ ದಿಸ್ ಈಕ್ವೇಶನ್. ಸೊ V minus U ಅಂದ್ರೆ ಏನಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೋದು, A into T ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಏನ್ ಬರುತ್ತೆ ನಮ್ಗೆ ಆಗ, X is equals to, so U into T plus half into T into V minus U can be substituted as AT, or this will give us our final equation. X is equals to UT plus half AT square. Okay, X is equals to UT plus half AT square agate. Okay, so this is just a simple graphical based derivation, very simple. First step, what we did to find out V is equals to U plus AT, we just consider the definition of acceleration and we got it. And in the next step, what we did, we just consider displacement of the particle na X anta tagondre, this will be equal to area under VT graph. So that's all we did. We found out the area under velocity time graph, and that is what is going to give us the second equation of motion. Okay, UT plus half AT square. Is that clear? X is equals to UT plus half AT square. So this is second equation of motion. Now we will try to get the third equation of motion. Again for that we no need this graph anymore. We just need to consider the previous equation and we can do it. So let me just keep for our reference, that's all. The same graph I have put in the 3 slides. Okay, so they are not something different. So it will become easy for discussion. So I just have pasted it 3 times. Okay, so what we are doing, so we have to derive the third equation of motion, correct? So for that, what we will do is, the displacement of the particle, that is X, will be equal to average velocity into time anta baribodu, correct? Because average velocity heng define madirtivi, displacement by time anta, correct? Delta X by delta T anta define madirtivi. V average is delta X by delta T anta madirtivi. Illi delta X andre enagide, it is like X minus 0 alva, X minus 0 by T minus 0 tara ide. So from here I can say my displacement is velocity into time. That's all I want to say. V average into time, correct? So I'm taking this. This is for your reference. No need to write in the exam. You can start from this point. X is equals to V average into time. So average velocity henge baribodu, when we know the two extreme ends of the velocity. Initial velocity enide V average can also be given by V plus U by 2. Can I write like this? This is possible, yes or no? You can write average velocity as V plus U by 2. Initial value plus final value divided by 2, correct? Two extreme ends gottidre average heng find out martira. So you just add them and divided by 2. It is possible only if acceleration is constant throughout. Okay, into time anta baritivi again. ಸೊ ವಿಲ್ ಗೋ ಬ್ಯಾಕ್ ಟು ಅವರ್ ಫಸ್ಟ್ ಈಕ್ವೇಶನ್. ಸೊ ಇಲ್ಲಿ ಟೈಮ್ನ ಏನು ಬರಿಬೋದು, v minus u by t ಅಂತಾನು ಬರಿಬೋದು, ಕರೆಕ್ಟ್, ಫ್ರಮ್ ದಿಸ್ ಈಕ್ವೇಶನ್. ಸೊ ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ರೈಟ್ ದೇರ್. I hope I'll just write here. So from v minus u is equals to a into t idella. So from here t can be written as v minus u by a anta baribodu. That is from our star equation, correct. So I'll substitute here. En barutte nangaga x is equals to v plus u by 2 into v minus u by 2 ಆಗುತ್ತೆ, correct. Sorry, v minus u by a ಅಲ್ಲಿ, this is a, ಟೈಮಿಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ, v minus u by a, or this can be rewritten as 2ax is equals to v plus u into v minus u, or ಇದನ್ನ ಫರ್ದರ್ ಒನ್ ಸ್ಟೆಪ್ ರೀರೈಟ್ ಮಾಡ್ಬೋದು. ಏನು ಬಂದಿದೆ ನಮಗೆ, v plus u into v minus u is equals to 2ax ಅಂತ ಬಂದಿದೆ. I just had written in the LHS on the other side and the RHS on the other side, interchange ಮಾಡಿ ಬರ್ದಿದ್ದೀನಿ ಅಷ್ಟೇ. ಸೊ v plus u into v minus u is equals to 2ax ಅಂತ ಬರಿಬೋದು. ಈಗ we know that the formula from your high school, a square minus b square ಇದ್ರೆ ಹೆಂಗೆ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡ್ತೀರಾ, a plus b into a minus b ಅಂತ ಬರೀತೀರಾ, ಕರೆಕ್ಟ್. ಸೊ ಇಲ್ಲೇನಾಗಿದೆ, v plus u into v minus u ಇದೆ. ಸೊ ದಿಸ್ is nothing but v square minus u square is equals to 2ax ಅಂತ ಹೇಳ್ಬೋದು, or this will give us v square is equals to u square plus 2ax. Okay, so I just have sent this minus u square on the other side. So ಏನು ಬಂದಿದೆ ನಮಗೆ, v square is equals to u square plus 2ax ಬಂದಿದೆ. Okay, hope it is clear. Yes, Shrikant, I think you are still following the session. So this is our third equation or third kinematic equation of motion. Okay, so one is v is equals to u plus at. The second one is ut plus half at square equals to displacement x, and the other one is v square is equals to u square plus 2ax. So the three kinematic equations of motion. V is equals to u plus at, v square, okay, the other one first we'll write, x is equals to ut plus half at square, and v square is equals to u square plus 2ax. This is if the motion started from origin. Okay, origin in the motion start agidre, if the particle started from the origin, that is x is equals to 0 ಇಂದ some x ತನಕ ಹೋಗಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಈಕ್ವೇಶನ್ ಈ ತರ ಬರುತ್ತೆ. Okay, hope it is clear. We can go ahead, I guess. Any doubts? Please raise your doubt there. Yeah, no doubts. So the other case, if the particle initially started from the position x naught instead of origin, let me say, if the particle started from x naught initially, this is just a slight modification, okay, such that this x naught is not equal to 0, origin in the start madilla andre. So ಆಗ ಏನಾಗುತ್ತೆ, replace x by x minus x naught. So in the previous equation, wherever we had x, no, so just replace x by x minus x naught. Okay, x ಇರೋಲ್ಲ, x minus x naught ಅಂತ ರಿಪ್ಲೇಸ್ ಮಾಡಿ. ಸೊ ಫಸ್ಟ್ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ಏನೂ ಚೇಂಜ್ ಆಗಲ್ಲ, ಅಲ್ಲಿ ಎಕ್ಸ್ ಡಿಪೆಂಡೆನ್ಸಿನೇ ಇಲ್ಲ, v is equals to u plus at. ಸೆಕೆಂಡ್ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ಏನಿದೆ, x ಅಂತ ಇದೆ, ಸೊ ದ್ಯಾಟ್ ವಿಲ್ ಬಿ x minus x naught is equals to ut plus half at square ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅವರ್ ಸೆಕೆಂಡ್ ಈಕ್ವೇಶನ್. ಸೊ ಇಲ್ಲಿ x ಇದೆ, ಅದನ್ನ x minus x naught is equals to ut plus half at square ಅಂತ barde, or this can also be written as x is equals to x naught plus ut plus half at square antanu baribodu. Okay, I just take that minus x naught to the other side. That's all I did. Okay, so initially 0 badlu some 5 meter in the start agide, some 50 meter in the start agide object motion. So origin in the start agilla andre just aa x naught na illi add madಕೊಳ್ಳಿ ಅಷ್ಟೇ. Okay, and third equation of motion enide, we had like v square is equals to u square plus 2ax anta ide. So allu ade change agutte, v square is equals to u square plus 2a into x minus x naught agutte. Okay, v square is equals to u square plus 2a into x minus x naught agutte. Okay, so these are the three equations of motion if the object has not started from the origin. Slight modification ಅಷ್ಟೇ, ಅಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಅಲ್ಲಿ x naught ಟರ್ಮ್ ನ 0 ತಗೊಂಡಿರ್ತೀವಿ. ಸೊ x naught 0 ಆಗಿಲ್ಲ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಎಲ್ಲ ಕಡೆ ಆ ಟರ್ಮ್ ಉಳಿತಾ ಬರುತ್ತೆ ಅಷ್ಟೇ. ಓಕೆನಾ? ಸೊ ಎನಿ ಡೌಟ್ you can ask in your chat box, and if you have understood you can give me a thumbs up in the chat box, or you can like this session. So we can just move ahead to one more concept, that is equations of motion under gravity. So ide three equation of motion enidalla namge, v is equals to u plus at, I'll just rewrite that first, and then we have v square is equals to u square plus 2a x antanaru tagoli s antanaru tagoli, some book may refer as s. Okay, v square is equals to u square plus 2ax and x is equals to ut plus half at square ide. So these are the three equations of motion. Illi motion under gravity andre, okay, most of the time we'll be talking about free fall case tagondirthivi. Okay, so free fall andre enu, once you drop the object, okay, so we are dropping the object freely under gravity. Okay, dropping the object freely under gravity. So ಇಲ್ಲಿ dropping ಅಂದ್ರೆ initial velocity 0 ತಗೊಂಡಿರ್ತೀವಿ, ಅದು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Sometime you can just throw with some initial velocity. So usually dropping case ಅಂದ್ರೆ initial velocity 0 ತಗೊಂಡಿರ್ತೀವಿ. So that I'll consider when we are discussing the problem. Right now I don't consider u. Okay, so u as 0 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿರಲ್ಲ, ಬಟ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ ಫ್ರೀ ಫಾಲ್ ಕೇಸ್ ತಗೊಂಡ್ರೆ u 0 ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಗ್ರಾವಿಟಿ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಆಕ್ಟಿಂಗ್ ವರ್ಟಿಕಲಿ ಡೌನ್ವರ್ಡ್. ಕರೆಕ್ಟ್, ಗ್ರಾವಿಟಿ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಆಕ್ಟಿಂಗ್ ವರ್ಟಿಕಲಿ downward. Okay, acceleration due to gravity, correct? So because of the earth gravitational pull, so if I drop anything, it will be attracted towards the, it will be attracted towards the earth agirutte. So at what, as the object reaches the ground, its velocity increases. That is absorbed by, Galileo, and that's what we call it as the acceleration gained by the body because of the earth gravity. We call it as acceleration due to gravity. Okay, because of the earth gravitational pull, whatever the acceleration gained by the body, okay, so that we call it as acceleration due to gravity, and it has a magnitude like 9.8 meter per second square. Magnitude enagirutte 9.8 meter per second square agirutte. Okay, is that clear? Hope you are following. Any doubts, ask in the chat box. Okay, so and the direction is always vertically downward. Okay, so now vertically downward irodrinda, so I will usually stick to a sign convention. Okay, so en martini, I take, if you just consider your coordinate axis, this is our plus x anta tagotivi, this is our minus x axis anta tagotivi, this is our plus y, this is our minus y axis. Correct? So vertically downward direction andre enu, ee direction agirutte. Correct? So ee direction na always negative tagotini, and upward direction na always positive tagotini. Okay, ಅದೇ ತರ ಇಫ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮೋಷನ್ ಇಸ್ ಅಲಾಂಗ್ ಪಾಸಿಟಿವ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇದ್ರೆ ಇದನ್ನ ಪಾಸಿಟಿವ್ ತಗೋತೀನಿ, ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೋಷನ್ ಇದ್ರೆ ನೆಗೆಟಿವ್ ತಗೋತೀನಿ. ಬಿಕಾಸ್ ಇಲ್ಲಿ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನೀವು ಎಕ್ಸ್ ನ ಪಾಸಿಟಿವ್ ತಗೋಬೇಕಾ, ವಿ ನ ಪಾಸಿಟಿವ್ ತಗೋಬೇಕಾ, ಎ ನ ಪಾಸಿಟಿವ್ ತಗೋಬೇಕಾ, ಆ ಡೌಟ್ ಬರುತ್ತೆ. ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಿಕ್ ಟು ಎ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ವೇರ್ upward positive, downward negative, positive x-axis, positive x-axis is positive and the towards left side ಏನಿದೆ ಅದನ್ನ ನೆಗೆಟಿವ್ ತಗೋತೀರಾ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡೋಣ. ಓಕೆ, ಅಂಡ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಏನ್ ತಗೋತೀವಿ, ಇಫ್ ದ ಫೈನಲ್ ಪೊಸಿಷನ್ ಇಸ್ ಬಿಲೋ ದಿ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್, ಆ ಕೇಸಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ನೆಗೆಟಿವ್ ತಗೋತೀನಿ. ಇಫ್ ಫೈನಲ್ ಪೊಸಿಷನ್ ಇಸ್ ಅಬೋವ್ ದಿ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್, that displacement I take it as positive. Okay, for example, I throw a ball up, so the displacement of the ball till the maximum height I take it as positive displacement. Okay, initial position below idre than your final position, so that is positive displacement. Final position is below the initial position adre negative displacement. So ಆ sign convention follow ಮಾಡ್ತೀನಿ. So ಈಗ ಇಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು, acceleration in this case will be replaced by acceleration due to gravity, that is g. So usually notation ಏನು, small g ಅಂತ represent ಮಾಡ್ತೀವಿ, correct? Acceleration due to gravity is represented by the symbol small g. Okay, it is the acceleration gained by the body due to earth's gravity. Okay, so ಅದರ representation ಏನಿರುತ್ತೆ g ಅಂತ ತಗೋತೀವಿ, which has a constant value like 9.8 nearly. Okay, so ಈಗ wherever we see acceleration in our equation, replace by minus g, because my sign convention what I am following is that I am taking the downward direction always negative, because ಒಂದೊಂದು ಬುಕ್ಕಲ್ಲಿ ಒಂದೊಂದು ತರ ಇರುತ್ತೆ. whichever you are comfortable, you are free to follow, but stick to one type of sign convention. Either you stick to the sign convention what I say, or stick to the sign convention which you have already followed. Don't mix both. That's the only kind suggestion for you. So ಏನು ಮಾಡೋಣ ಈಗ, if I just write down the equations of motion under gravity, so ಏನು ಬರುತ್ತೆ, v is equals to u minus gt ಆಗುತ್ತೆ. Then we had the second equation as v square is equals to u square minus 2gx ಆಗುತ್ತೆ. And the other one is x is equals to ut minus of gt square ಆಗುತ್ತೆ. Okay, with the sign convention I had given, you can follow with this equation. ನೀವು ಬೇರೆ sign convention ತಗೊಂತಿದ್ರೆ it is not going to be always negative, because some books will say along the direction of motion ಅನ್ನು ಅವ್ರು ಪಾಸಿಟಿವ್ ತಗೋತಾರೆ, opposite to the direction of motion ಅನ್ನು ನೆಗೆಟಿವ್ ತಗೊಂಡಿರ್ತಾರೆ. So if you are following that, stick to that, no problem. At the end of the day same answer ಬರುತ್ತೆ problem solve ಮಾಡಿದಾಗ. But if you are sticking to my sign convention, please follow this way of representing the equations of motion. Okay, hope it is clear. Any doubt? Please ask your doubts in the chat box. Okay, no doubts I guess. So in this sign convention you can also just mention, that is initial position, I'll take it as IP, is above final position ಇದ್ರೆ ಆಗ x ನ ಏನು ಮಾಡಬೇಕು ನೀವು, initial position is above the final position ಇದ್ರೆ x is negative, that is displacement is negative. If final position, okay, so final position is above the initial position, x is positive. Okay, so this will be the easy sign convention to follow. Okay, so it's like for an upward motion, like I throw a ball up, so final position ಮೇಲೆ ಇರುತ್ತಲ್ವಾ, I mean I'm not considering its downward journey. So let us, for an upward motion, so ಏನಾಗಿರುತ್ತೆ, displacement positive ಇರುತ್ತೆ, acceleration due to gravity downward ಇರುತ್ತೆ, which will be negative. So in the same way if I just drop a ball, ಏನಾಗುತ್ತೆ, downward journey, correct? So ಅಲ್ಲಿ initial position some height ಇರುತ್ತೆ, final position ground ಇರುತ್ತೆ. ಸೊ ಆ ಕೇಸಲ್ಲಿ yeah, x is going to be negative. Okay, initial position is above the final position. Male idre it is going to be negative. Hope it is clear. Yeah, so one more I will do, that is by calculus method. Okay, deriving the kinematic equation by calculus method. So one the derivation mana. Okay, the remaining one or two we can discuss as the problem in our practice session. Okay, so by calculus method if we try to derive, so calculus method andre either integration or differentiation. Okay, integration and differentiation method alli derive ಮಾಡ್ತೀವಿ. So first we will consider the, again ಇಲ್ಲಿ starting step by the definition we will consider acceleration definition. Okay, so acceleration ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ, a is equals to dv by dt ಅಂತ ಬರೀತೀವಿ. Okay, or I'll just rewrite this, dv is equals to a into dt ಅಂತ ಬರೀತೀನಿ. Okay, so ಇದು fractional change in velocity ಬರ್ತಾ ಇದೆ ನನಗೆ. I want how totally the velocity is changing over a given interval of time. So for that ಏನು ಮಾಡ್ತೀವಿ, ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡ್ತೀವಿ. Okay, so ಏನು ಮಾಡಬೇಕು, ಇಂಟಿಗ್ರೇಟಿಂಗ್. ಸೊ ಇಂಟಿಗ್ರೇಷನ್ ಸಿಂಬಲ್ ಏನು ಇದು. ಓಕೆ, ಸೊ ಇಂಟಿಗ್ರೇಷನ್ ಅಂದರೆ ಹೀಗೆ ಬರಿತೀವಿ, ವೆರಾಸ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಅಂದರೆ ಡಿ ಬೈ ಡಿ ಟಿ ಆರ್ ಡಿ ಎಕ್ಸ್ ಆ ಥರ ನೊಟೇಷನ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಇದೊಂಥರ ಸಮೇಷನ್ ಥರ. ಇಂಟಿಗ್ರೇಷನ್ ಅಂದರೆ ಸ್ಮಾಲ್ ಸ್ಮಾಲ್ ಪೀಸಸ್ ಇದೆ, ಯು ಆರ್ ಆ್ಯಡಿಂಗ್ ಇಟ್. ಸೊ ಆ ಸಮೇಷನ್ ಅಲ್ಲಿ ಎಸ್ ಅನ್ ಬರುತ್ತಲ್ಲ ಅದನ್ನೇ ಈ ಥರ ಸಿಂಬಲ್ ಆಗಿ ತಗೊಂಡಿರೋದು. ಓಕೆ, ಸೊ ಇಂಟಿಗ್ರೇಷನ್ ಡಿ ವಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಡಿ ಟಿ ಅಂತಿದೆ. ಸೊ ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ತನಕ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡ್ತೀನಿ, ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ಯು ಟು ಸಮ್ ಫೈನಲ್ ವೆಲಾಸಿಟಿ ವಿ, and ಈ ಕಡೆ ಯಾವುದು ಟೈಮ್ ಇಸ್ ದಿ ವೇರಿಯಬಲ್. ಸೊ ಟೈಮ್ ಟಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು 0 ಟು ಸಮ್ ಟೈಮ್ ಟಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಟಿ ವರೆಗೆ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡ್ತೀನಿ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಲಿಮಿಟ್ ಆಫ್ ಇಂಟಿಗ್ರೇಷನ್. ಓಕೆ, ವಿ ಆರ್ ಇಂಟಿಗ್ರೇಟಿಂಗ್ ಅಂಡರ್ ದಿ ಲಿಮಿಟ್ಸ್. ಓಕೆ, ಸೊ ಈಗ ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಡಿ ವಿ ವಿಲ್ ಗಿವ್ ಮಿ ವಿ. ಓಕೆ, ಫ್ರಮ್ ದಿ ಲಿಮಿಟ್ ಆಫ್ ಯು ಟು ವಿ is equals to, so acceleration is constant, I will take it out. Integration of dt will give me t itself. Integration of dv will give me v. Integration of dt will give me t from the limit of 0 to t. Okay, so ಇಲ್ಲಿ ಒಂದು integration formula ಕೊಡ್ತೀನಿ, ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡಿ. So integration of x raised to n dx is going to give you x raised to n plus 1 by n plus 1. So ಇದು exactly opposite of your differentiation. Differentiation x raised to n differentiation ಏನು, n into x raised to n minus 1 ಬರ್ದಿದ್ರಿ, ಇಲ್ಲಿ n plus 1 divided by n plus 1 ಆಗುತ್ತೆ. x raised to n plus 1 divided by n plus 1 ಆಗುತ್ತೆ. Please remember this formula. Okay, and ಇಲ್ಲಿ again ಈ x raised to ಇಲ್ಲಿ ಏನು ಮಾಡಿದೆ ನಾನು, dv integration v ಅಂತ ಬರ್ದೆ ಅಲ್ವಾ. It is just like x raised to 0 into dx ಅಂದ್ರೆ ಏನು, it is nothing but integration of dx ಅಲ್ವಾ, because anything raised to power 0 ಅಂದ್ರೆ 1, ಕರೆಕ್ಟಾ. ಸೊ ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಡಿ ಎಕ್ಸ್. ಸೊ ಎಕ್ಸ್ ರೈಸ್ ಟು 0ನ ಈ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿ, ಏನಾಗುತ್ತೆ, ಎಕ್ಸ್ ರೈಸ್ ಟು 0 plus 1 by 0 plus 1 which is nothing but equal to x. ಅದನ್ನೇ ನಾನಿಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡೋದು. ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಡಿ ವಿ ವಿಲ್ ಗಿವ್ ಮಿ ವಿ, ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಡಿ ಟಿ ವಿಲ್ ಗಿವ್ ಮಿ ಟಿ, ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಡಿ ಎಕ್ಸ್ ವಿಲ್ ಗಿವ್ ಮಿ ಎಕ್ಸ್, ಲೈಕ್ ದಟ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಮೈನಸ್ ಲೋವರ್ ಲಿಮಿಟ್ ಮಾಡಬೇಕು. ಲಿಮಿಟ್ಸ್ ಇದ್ರೆ ಆಫ್ಟರ್ ಇಂಟಿಗ್ರೇಷನ್ ಯು ಹ್ಯಾಡ್ ಟು ಅಪ್ಲೈ ದಿ ಲಿಮಿಟ್. ಹೌ ಡು ಯು ಅಪ್ಲೈ, ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಮೈನಸ್ ಲೋವರ್ ಲಿಮಿಟ್ ತರ ಮಾಡಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ಲೈಕ್ ವಿ ಮೈನಸ್ ಯು, ಇಲ್ಲಿ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಇಸ್ ವಿ, ಲೋವರ್ ಲಿಮಿಟ್ ಇಸ್ ಯು. ಸೊ ಅದನ್ನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು, ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಮೈನಸ್ ಲೋವರ್ ಲಿಮಿಟ್. ಓಕೆ, ಒನ್ ಸೆಕೆಂಡ್. ಸೊ ಇಲ್ಲಿ just a second. Yeah. This is UL minus LL anta baritini. That's what I wanted to do. So upper limit na UL anta bariyana minus lower limit. Okay, so V minus U is equals to A into T minus 0 ಆಗುತ್ತೆ. or in one step ಬರೆಯೋಣ. So ಏನು ಬರುತ್ತೆ, v minus u is equals to a into t ಆಗುತ್ತೆ, or we wanted v is equals to u plus at. Okay, so this is how we get the first equation of motion by calculus method. Okay, similarly I'll just give you a hint and I will leave it to work out for you. Okay, you can try it, or else anyway in the next session we will be deriving them by the calculus method as a problem also. Okay, so in mana hint is, consider definition of velocity v is equals to dx by dt, or idana rewrite ಮಾಡಬಹುದು, that is dx is equals to v dt. so idana itkondo, okay, ಇಲ್ಲಿ v ಗೆ substitute ಮಾಡಿ u plus at ಅಂತ, try to arrive at the second equation of motion. ಯಾವುದು, ಈ equation derive ಮಾಡಿ. x is equals to ut, I mean ಇದು g ಅಲ್ಲಿದೆ, so ಏನು ಹೇಳ್ಬೋದು, ut plus half at square ಇದಲ್ಲ, so ಈ equation you can try to derive. Okay, so just by considering the definition of velocity, okay, so this is up to you to work out. I'm just leaving with a hint. Consider the velocity definition, v is equals to dx by dt, ಅದನ್ನ rewrite ಮಾಡನು ಕೊಟ್ಟಿದ್ದೀನಿ. Okay, and next step ಏನು ಮಾಡಬೇಕು, velocity ಗೆ substitute ಮಾಡಿ ಇದೇ ತರ integrate ಮಾಡಬೇಕು. ಏನು, ಇದೇ ತರ integrate ಮಾಡಬೇಕು, same formula workout ಆಗುತ್ತೆ. Okay, x raised to n dx integration will be x raised to n plus 1 divided by n plus 1, same formula ಹಾಕಿ, so you will get that. Okay, ಇಲ್ಲಿ ಲಿಮಿಟ್ ಏನಾಗಿರುತ್ತೆ, x0 to x ಆಗಿರುತ್ತೆ ಲಿಮಿಟ್, ಬಿಕಾಸ್ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್ x0 ಅಥವಾ ಆರಿಜಿನ್ ಅಂತ ತಗೊಂಡಿರ್ತೀವಿ. ಸೊ ದಟ್ಸ್ ಅಪ್ ಟು ಯು, 0 to x ಆರು ತಗೊಳ್ಳಿ, x0 to x ಆರು ತಗೊಳ್ಳಿ. ಅಂಡ್ ಇಲ್ಲಿ ಟೈಮ್ ಐ ಮೀನ್ ಡಿ ಟಿದು ಏನಾಗಿರುತ್ತೆ, ಅಪ್ಪರ್ ಲಿಮಿಟ್ t is equals to 0 to t is equals to t, correct? t is equals to 0 to t is equals to t. Okay, 0 to t is the integral limit for the right hand side. Okay, ಯಾವುದು ಇಂಟಿಗ್ರಲ್ ವೇರಿಯೇಬಲ್ ನೋಡಬೇಕು, ಅದರ ಲಿಮಿಟ್ಸ್ ಏನು ನೋಡಬೇಕು, ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ತನಕ ವೇರಿ ಆಗಿದೆ ಅಂತ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಇಸ್ ಯುವರ್ ಇಂಟಿಗ್ರಲ್ ಲಿಮಿಟ್. ಓಕೆ, ಇಂಟಿಗ್ರೇಷನ್ ಆದ್ಮೇಲೆ ನೀವು ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಮೈನಸ್ ಲೋವರ್ ಲಿಮಿಟ್ ಮಾಡಬೇಕು. Okay, hope it is clear. Any doubt? Yeah, any doubts you can respond. Yes, Prarthana, very good. If you have tried, I think you are telling that you have did the calculus method of arriving at x is equals to ut plus half at square derivation, or x minus x naught is equals to ut plus half at square derivation. So if you have done, very good. So you can also try the other one. Okay, and anyway that we'll be discussing in the next practice question session as well. Okay, yes, if you have understood the concepts that are discussed today, you can like the session, and also you can subscribe to the channel to get more content in all the subjects. Okay, yes, okay, okay, Prarthana. Okay, then hope all of you have followed the complete session, and if you had any doubts, you are free to ask in the chat box. Okay, if somebody is still not, refer to the previous chapter, that is units and measurement chapter. Please refer to the units and measurement chapter as well for your revision for the upcoming test. Okay, which is available in all of them are available in one playlist, which you can check there. And also you can refer to the provided 2-mark and 3-mark questions for units and measurement chapter. Okay, so 5-mark question from that chapter will not be asked, so you can refer to the 2-mark question and 3-mark questions from the the other session, the second session on units and measurement. Okay, so with this I'm going to end the session for today. Thank you.